Determine the magnitude of the forces C and T, which along with the other three forces shown act on the bridge-truss joint. So in this problem, 5 forces are acting at a point. So this comes under coplanar concurrent system. The force of 8 kilonewton is acting at 0 degree and T kilonewton acting at 40 degree and 3 kilonewton acting at 90 degree and C kilonewton acting at 70 degree and 16 kilonewton acting at 0 degree with respect to x-axis. The T and C are unknown here. So the bridge truss joint will be stable and it will be in equilibrium. So the condition for equilibrium is summation f of x equals 0, summation f of y equals 0 and summation of moment equal to 0. Here 5 force system are considered. So this problem can be approached by scalar method, vector method and graphical method. So we can use roll and draw for graphical method for better accuracy. In scalar method, the following tabular column is created by taking force and angle with x-axis and horizontal component and vertical component. So the 5 forces are acting here: 8 kilonewton at 0 degrees, T kilonewton at 40 degrees, 3 kilonewton at 90 degrees, C kilonewton at 70 degrees and 16 kilonewton at 0 degrees. All the degrees are with respect to horizontal. Then horizontal component and vertical component are calculated. Horizontal component is calculated by force into cos theta and vertical component is calculated by force into sin theta. And summation f of x is found out by 8 cos theta 0 plus t cos 40 minus 3 cos 90 plus c cos 70 minus 16 cos 0. And solving this, we will be getting summation f of x equals 0.766t plus 0.342c minus 8. Coming to the vertical component, summation f of y can be calculated by summing up all the individual vertical components: 8 sin 0 plus t sin 40 minus 3 sin 90 minus c sin 70 plus 16 sin 0. Here upward forces are taken as positive and downward forces are taken as negative. On solving, we will be getting summation f of y equals 0.6427t minus 0.9397c minus 3. On solving this, we have 2 equations and 2 unknowns. On solving this, we will be getting T as 9.093 Newton and C as 3.026 Newton. Coming to the vector method, we can take the forces along x-axis as I and forces along y-axis as j and forces along z-axis as k. So this problem, only the 2-dimensional problem, only I and j are considered. So from the force diagram, we can write 8I plus t cos 40 of I plus t sin 40 of j minus 3j plus c cos 70i minus c sin 70j minus 16i. Here x components are taken as I and y components are taken as j. And equating the coefficients of I and j to 0, we will be getting 8 plus t cos 40 plus c cos 70 minus 16 equal to 0 and t sin 40 minus 3 minus c sin 70 equal to 0. On solving this, we will be getting T as 9.093 Newton and C as 3.026 Newton. The same problem can be approached by graphical method. We can use roll and draw for better accuracy. For drawing in the graphical method, we want to draw the space diagram accurately and represent all the angles with respect to x-axis. Initially, for 16 kilonewton, We draw a line parallel to 16 kilonewton. We can take suitable scale 1 Newton as 5 mm. So for 16 kilonewton, we can take 8 mm horizontally to the 16 kilonewton force. Similarly, for 3 kilonewton force, draw the vertical line representing 3 kilonewton. For 8 kilonewton force, draw parallel line representing 8 kilonewton. For T kilonewton, we don't know the magnitude, we know the direction. So draw the parallel line representing the 40 degrees. Similarly, for C, we don't know the magnitude, only the direction is known. 70, draw a parallel line representing 70 degrees connecting at the 8 kilonewton vector. So the force polygon is drawn. And after that, measure T and C and convert 5 mm as 1 Newton. On measuring and converting, we will be getting T as 9.09 Newton and C as 3.0.